Welcome back to Cyber Genius, where we explore the cutting edge of technology. I'm your name, and today we're diving into the mind-bending world of quantum computing. Imagine a computer so powerful that it can solve complex problems in seconds, problems that would take classical computers millions of years to crack. That's the promise of quantum computing, and it's not just science fiction anymore. Over the next hour, we'll unravel the mysteries of quantum mechanics, explore current advancements, and discuss the revolutionary impact quantum computing could have on our future. So, what exactly is quantum computing? To understand that, we need to take a quick look at quantum mechanics, the bizarre and fascinating branch of physics that governs the behavior of the very small. When we talk about quantum computing, we're essentially discussing how we can leverage the principles of quantum mechanics to process information in radically new ways. In classical computing, the basic unit of information is a bit, which can be either a 0 or a 1. But in quantum computing, we use qubits. A qubit, thanks to the principle of superposition, can be both 0 and 1 at the same time. This is a game changer because it allows quantum computers to process a massive amount of information simultaneously. Quantum mechanics is the branch of physics that deals with phenomena on a very small scale, like atoms and subatomic particles. It's here that we encounter some mind-boggling concepts. First, there's the qubit, which can exist in a state of superposition, meaning it can be both 0 and 1 at the same time. This is unlike classical bits, which are either 0 or 1. Then there's entanglement, another fundamental quantum principle. When two qubits become entangled, the state of one instantly influences the state of the other, no matter how far apart they are. This interconnection can lead to exponential increases in processing power. Imagine a giant library where you have to find one specific book. A classical computer would go through each book one by one, but a quantum computer, using superposition and entanglement, could look at all the books simultaneously and find the right one almost instantly. Let's bring this down to earth a bit. Here's a model of a quantum computer. It might look similar to a classical computer, but under the hood, it's completely different. Classical computers use silicon-based processors. Quantum computers, on the other hand, use quantum processors that operate at extremely low temperatures, just above absolute zero, to maintain their quantum state. One of the most famous quantum processors is IBM's Q System 1. It uses superconducting qubits and operates in a dilution refrigerator. The complexity of keeping these qubits in a stable state is immense, which is one of the major challenges in building scalable quantum computers. But the potential benefits are staggering. Quantum computers can solve optimization problems, simulate molecular structures for drug discovery, and even break classical encryption methods, which we'll talk about in more detail later. To delve deeper into the current state of quantum computing, I'm joined by Dr. Eppersname, a leading researcher in the field. Doctor, thank you for joining us. It's a pleasure to be here. Can you tell our viewers a bit about the current advancements in quantum computing? Absolutely. Over the past few years, we've seen significant milestones. For instance, in 2019, Google announced that their quantum computer, Sycamore, achieved quantum supremacy by solving a problem in 200 seconds that would take a classical supercomputer 10,000 years. While this was a specific narrow task, it was a huge proof of concept. That's incredible. What about the hardware side? How are companies like IBM and Microsoft advancing quantum technology? IBM has been leading with their Q-Experience platform, making quantum computing accessible to researchers and enthusiasts worldwide. They continue to improve their quantum volume, a metric that measures the performance and capability of a quantum computer. Microsoft is taking a different approach with their topological qubits, which promise greater stability and error correction. Speaking of error correction, that's one of the big challenges, right? Exactly. Quantum bits are extremely fragile and can lose their state due to slightest interference from their environment. Developing robust error correction techniques is crucial for building reliable quantum computers. Thank you, Doctor, for these insights. It's an exciting time for quantum computing. Now let's explore some of the groundbreaking applications of quantum computing. One of the most promising areas is cryptography. Quantum computers can break widely used encryption methods, such as RSA and ECC, by quickly factoring large prime numbers. This poses a significant threat to current cybersecurity protocols. However, quantum technology also offers solutions. Quantum key distribution, QKD, leverages the principles of quantum mechanics to create theoretically unbreakable encryption. Any attempt to eavesdrop on the communication alters the quantum states, alerting both parties of the intrusion. Another exciting application is in drug discovery. Quantum computers can simulate molecular interactions at an atomic level, which is impossible for classical computers due to the sheer complexity. This capability can accelerate the development of new medications and materials. Optimization problems, which are ubiquitous in industries like logistics, finance, and manufacturing, can also benefit from quantum computing. Quantum algorithms can find optimal solutions much faster than classical algorithms, improving efficiency and reducing costs. Despite the incredible potential, there are significant challenges and limitations to overcome. One of the biggest hurdles is quantum decoherence, where qubits lose their quantum state due to environmental interference. This requires extremely low temperatures and isolation, making quantum computers expensive and complex to maintain. Scalability is another issue. Building a quantum computer with enough qubits to solve practical problems while maintaining error correction is a monumental task. Researchers are working on developing fault-tolerant quantum computers, but we're still in the early stages. Moreover, there are ethical and security concerns. The ability to break current encryption methods could have drastic implications for data privacy and national security. It's crucial that we develop new cryptographic techniques in parallel with advancing quantum technology. So what does the future hold for quantum computing? Many experts believe that within the next decade, we could see practical quantum computers that outperform classical computers in certain tasks. This doesn't mean classical computers will become obsolete, but rather, we'll have hybrid systems where quantum computers handle specific complex problems. Industries like pharmaceuticals, materials science, and logistics will be among the first to benefit. Quantum computing could lead to breakthroughs in developing new drugs, designing advanced materials, and optimizing supply chains. For those interested in getting involved, now is a great time to start learning about quantum computing. Universities and online platforms offer courses on quantum mechanics, computer science, and quantum programming languages like Qiskit and Cirq. Investment in quantum startups is also growing, with significant funding from both private investors and government initiatives. Keeping an eye on this space could provide opportunities for career growth and innovation. To sum up, quantum computing represents a monumental leap in technology, promising to solve problems that are currently intractable for classical computers. While we face significant challenges, the progress made so far is encouraging, and the potential benefits are immense. Stay tuned to CyberGenius as we continue to explore the fascinating world of advanced technology. If you enjoyed this video, don't forget to like, share, and subscribe. Leave a comment below on what aspect of quantum computing you're most excited about, or if you have any questions. Until next time, stay curious and keep learning.